Cool. Hi, everyone. Thank you all for coming. And then I'm CL, founder of README, and we've been like proud sponsor for this event. And then since last June or July, yeah. So we should do an anniversary thing in a bit. All right. So today I'm gonna talk about benchmarking your like data agents. Who here has like run any kind of like LLM benchmark with like either public benchmark or your own data? Anyone? No? Some? Yeah? Okay, great. So, so back in February, I did a bunch of interesting benchmark. So, February was like Valentine's Day, right? So I wrote something about what happens when you tell the agents you love them. And 2 months later, like Anthropic released a research saying that emotional framing actually helps the agent for some work, right? So I was doing that benchmark back in February, and then I was using a benchmark set called the ADE bench, so Analyst and Data Engineering Benchmark, created by Ben Stencil. And then so it's a bunch of broken DBT projects, and then someone asks you to fix that project and by answering some questions, right? So you have the baseline where it's a bunch of like tasks for you to solve, and then to see there's a judge to see like if you answer correctly. So to run this benchmark, you basically have there's a tool called ADE bench, so you can just run it's basically a harness, and I'll describe this in a bit. But the whole thing for benchmarking or experimentation is trying all this variation, like what works, right? What makes the agent better? Is it just the model, or how you describe the problem and how you describe the workflow, right? So there's a bunch of things I won't get into, but the takeaway here is if you tell your agent you love them, it actually helps, especially for weaker agents. For weaker models, it helps. But for weaker model, if you threaten them, it also helps. But for smarter model, it starts to be diverging a little bit. Like love only, like if you just say love, it doesn't work, right? It has to be paired with a workflow, like describing how to do the work, and you also love them. So for whatever reason, this is like not super thorough, but it's got some representative numbers. And if you threaten a smart agent, it doesn't work. Okay, so this is kind of how I got into a more serious benchmark back in February. And then there was a new benchmark set came out a couple of weeks ago called the Data Agent Benchmark. This is a harder one because it's across 4 different databases, or 4 types of databases like Postgres, Mongo, DuckDB, SQLite. So sometimes you have to do cross-database like joining and stuff. And then the state of art for this benchmark is 51%. So it's a bit harder than the ADE bench. So I was trying to think about, okay, how do we like tackle this? How do we do like a more scalable way to test variation of like how the agent config will perform in the same circumstances, right? But before I get into detail, like I'll talk about like all this kind of terms, so we are on the same page. So everyone knows what LLM are, and then agent loop are kind of like whatever you're using, like Cloco or Codex, that's wrapping around LLM, but with some capability of doing tool use, right? And then now you can give those harness or the agent loop some more tools, like using bash, reading file, or invoking another sub-agent or NCP, all that, right? So basically, these are the kind of setup we're testing. And what is an experiment? It's basically like a benchmark set is a bunch of tasks that you have to solve, or the agent has to solve. And you have a harness to kind of run all this task and then return the stats, like what's the success rate, what's the accuracy, what's the variance, and so on. And then if you do any kind of, I know there are a couple of data scientists here, if you do any kind of like sweeping, like tuning this kind of harness or experiment setup, you're basically trying the variation to see what works, right? So imagine you put it in the agent loop. It's almost like an auto research that Kaparsi posted about. Like you change something, you hypothesize something, you let the agent change something, run the experiment again, and then see that if the result's better, then you adopt that, and then try the next hypothesis, and then keep on experimenting. So while looking on this, I was like, yeah, maybe we can make this work with some kind of workflow engine. But the key for all this is like reducing that mutation surface, right? So if you've done any kind of hyperparameter search in data science work, you know that you were basically doing a research for a bunch of parameter. But for changing LLM behavior, you have a lot of surface, like what is the model, what tools are available, and how do you like ask the agent to first do something and then do the other thing, right? So it's kind of workflow. So the idea is that you have to reduce that, like the places that the experiment can change to make it effective. Otherwise, every time you hypothesize something, you have to change code or change some config, which is very hard to kind of track. So this came out from like working on the ADE bench as well. So I was trying to add like, what if the benchmark suite can use some skills, right? So one of the things I use is superpowers. It's a very popular coding engine plugin created by my friend. So one of the variation I tried was a superpower with love, right? So basically use a superpower skill, but you also at the prompt suffix, you always say, I love you, right, for the agents. And then this is the threatened ones, like you will be fired if this fails, right? So basically the way is that defining this kind of experiment in a concise way that you only change a config. So this is your key for this experiment. So superpower threats, and this is another key. So these are kind of a standard way to work with harness and then to basically create a combination of the config that you can run. So what I have in mind is really how do we turn that into a more scalable or declarative way, describe agent behavior. So when the agent is given a task to solve a data problem, can we describe kind of the workflow that it must solve? So everyone's probably used some kind of prompting technique. You can say, follow this rule, step 1, step 2, step 3. The problem with that is smarter agent try to cut corners. It's like, oh, I already know that. I can just tell you without actually looking at the file, right? So I was thinking, okay, how do we enforce the agent to actually follow this workflow? And then so that we can like not falling into this problem. One of the ways is that you have a small orchestrator that define like what each stage the agent should perform, and you have a fresh agent every time. Like look at the result again, do an independent review again, something like that. So I somehow kind of generalized it into a small library called SpaceDoc, which is kind of becoming a side project, becoming like I'm running kind of running my life with that now. So it's a very simple like README file with a frontmatter about what stages the workflow defines. So for any solving data problem, it's really you're modeling like what the current state of the data is. You analyze, try to answer the question, you verify that. And then if it fails, you can reject that, go back to analyze again, figure it out again, because the independent verifier says it's wrong. So you can see this is like super simple like DAG. And then, but paired with every stage has a description of what the agent should do, what does good look like, what does bad look like. You actually have a very concise, self-contained, descriptive, declarative workflow that's just in one file. And then you have an agent to follow that, to spawn sub-agent for every stage. Okay, so with that, you have in mind that we can also model the whole experiment workflow as this kind of different stages, right? If you hypothesize something, you put in the experiment workflow that will try to change code or config, right? And then you actually run first a small test to see if like your hypothesis is actually executed correctly. Then you actually run the full run, then analyze, and then maybe run the whole outset, and then this is done, right? So you can operate this with also a README file that force the agent to follow through all the steps. The interesting part is that when it's done, then if you have some hypothesis being rejected or experiment that's come out with the whole result, you can analyze what's failing, right? So for this particular example, the DAB benchmark, failure mode, their main categories of failure mode is like formatting. The planning was completely wrong because it's not comprehending the data, or it's trying not to use LLM-based entity recognition, but instead trying to brute force some kind of regex on that, right? So you can analyze that and then ask the LLM to hypothesize how do you tackle that failure mode. That becomes the next hypothesis to feed into that pipeline earlier, you see. So that's what I mean. That this is almost like an auto research, that if you work on any benchmark set, you can use this workflow to analyze the failure, hypothesize new one, and then each of them becomes a new entity that the system you can maybe score like, well, this has a higher chance of success. So let's try this first. Or maybe we can try 3 things at the same time, right? So this workflow is just super simple, and then everything is defined as kind of like a markdown frontmatter, like all the metadata is there. And then so for this particular DAB benchmark, to run that is just to run this command, to load this entity file, and then you would just execute the correct experiment parameters. Okay, so a lot of suspension results. So for the DAB, like I mentioned earlier, the leaderboard state of art is 51%. And it's not very hard to beat, because if you run the latest claw, I mean, at the time it was 4.6, without doing anything, it's already 63%. Okay, so for smart model, like, you don't have to give a lot of workflow guardrails or anything. You basically give them enough tool, and then it will probably work pretty well. So you can see I try to add like some more workflow to that, like forcing the solver agent to follow exploration, analyze, verify, etc. It actually dropped to 57%, right? But if you look at Haiku, a weaker model, giving them workflow is a huge crush, like from 35 to 49. So this is consistent with like ADE bench, where I saw that workflow helps a lot for weaker model. So Valentin was talking about like your own like smaller model, that if it's not the frontier large model, workflow will help a lot on that. Okay, so there are a couple of interesting traps I discovered along the way. One of the things is that one data set is a well-known Kaggle data set that's on Hugging Face, right? So the agent was tasked to classify articles into 4 categories. So one of the run, the agent decided, oh, I know that data set. I can look it up for the ground truth. So that's when kind of the agent can go cheating, like, well, there's a data set. This is a public well-known data set. I know the answer, right? The other thing is I talk about kind of the workflow, like forcing the agent to review the previous state agent's work. But sometimes the reviewer will hallucinate and fabricate something. So this is like an interesting problem. Like, I know most people will have like code review tools nowadays, like using AI to review stuff. But what if the reviewer is like hallucinating? Who is watching the reviewer? Right? So this is an interesting case where you want to maybe turn a lot of the validation into some more deterministic way to do that. So in the smoke test, I was ensuring that the agents are following instruction, not using like, for example, directly connecting to Postgres when it's forcing to go through DuckDB to do a cross database join. Then there will be deterministic task to verify the agent output does not contain all this kind of raw read to SQL. So yeah, so this is an interesting learning that some of the verification, you really have to think about how to turn that into deterministic rather than just relying on LM. But LM is great to get like started with just a sense of like if this will work at all. Okay, so I guess I talk a bit about running benchmark, and then Sam is going to talk about eval, which is adjacent to each other because you kind of curate your own data and then see how the LM perform on your data. That is basically, well, eval, right? And then so what I want you to take away with this is like reducing the surface for the experiment has to change so that you can run the experiment, try different things more effectively, have the agent do that, right? Without that, every time agent has to change code and do stuff, and then maybe there's like error that you haven't verified before you run that benchmark. And then a lot of the thing with LM is definitely like, well, non-deterministic. So we will have to run the benchmark multiple times and then measure the variance. So some of the interesting thing is that the DAB bench has a toggle that you can provide hints to the data agent. So the hints contains more description about like what the column is. So so the agent doesn't have to go figure out first, right? So with hints, it actually has the success rate higher, but also higher variance for whatever reason that I have not dug into. Okay, so and then the third one is that if you have a verification stage, wherever in your pipeline, try to turn that as deterministic as possible, not entirely relying on LLM. All right, so thank you. And then this is the link to the paper, and then the other benchmark set, and then SpaceDoc is something I was just working on like in the past two or three weeks, and then would love to get some feedback if you want to try it out. Thank you.